Hi, this is Dr. Jabali, and in this video, we're going to focus on questions from previous IB exams, which focus on topic 4.4, which is all about the greenhouse effect and the global warming and all those other questions related to it. So let's go ahead. Remember that when you're starting these questions, always look for the command word. It says describe. So when you see describe, it's not just words, you can also draw and annotate things. Now, the next thing you need to look is make sure you look at the points, because if the points are like 8 points, you really have to put 9 to 10 points there just to make sure. If it's 2 points, then it's more generalized, but even if it's generalized, make sure you go very specific on that one sentence. So now having this out of the way, let's go for the question. It says, describe the relationship between the rising concentration of atmospheric carbon dioxide and the enhanced greenhouse effect. So we are talking about how CO2 is rising and how this affects the greenhouse effect. First, I will always start with defining what is greenhouse effect. That's the most important. And this has to do with the ability to keep the Earth atmosphere warm, right? Because it's all the ability of keeping it warm for us. Now, with that, then I will mention about the greenhouse gases. What are the types of greenhouse gases? We have CO2, water vapor, methane, a couple of them. Then I will mention about how the sun emits short waves to the earth. And then how once the short waves bounce on earth, heat is lost. And then that becomes a long wave emitted by the earth, right? So the long wave is emitted by the earth to go outside the planet. However, in the middle of this case, we have the greenhouse gases. What do? They trap and absorb the long wave. So they basically are trapping what? Heat. And when they trap heat, it becomes more warmer. In this case, you can say the temperature, it just goes up. And this leads to global warming eventually in the long run. So this is the very, very straight to the point answers to this global warming. So the first thing I have to always mention is the definition. What is the greenhouse effect? It's the ability to keep the earth warm. Next, always mention what are the gases: water, vapor, CO2, methane. Then start with the process talking about how the sun sends short wave and how eventually some of that short wave bounce and release heat, and then it becomes a long wave which is emitted by the earth. So remember, short wave for the sun and long wave for the earth. And then after this, mention how the greenhouses trap this and absorb this long wave. So that means trapping heat, and that will increase the temperature, which can lead to global warming. So this is a very, very generic mark scheme that can be used every time you're talking about the greenhouse effect. So let's look at the mark scheme. See, I mentioned the greenhouse gases is CO2. Increase CO2 increases the greenhouse effect. And then greenhouse effect is a natural phenomenon, but it's not, but not its increase. So this is the only one that I have not mentioned, but I did mention these two. And then the earth receives short wave radiation from the sun, and then re-radiate from the earth as a longer wave. So these ones I have mentioned here. And then the greenhouse gases absorb or trap the longer wave radiation. Global warming happened during the same time period of CO2 as rises. So like I said, when I said the CO2 rises, we have more global warming. Concentration of CO2 is correlated with global temperature. As you said, the more CO2, that means the higher the temperature. It's the same thing. And then we have increased CO2 concentrations. The concentration increase as CO2 concentration increases. They're just basically saying that the temperature right here, the global temperature, is increasing. And then link accepted by most scientists. This is basically just now talking about the scientists believing or not. No proof of that man-made increase in CO2 have caused global warming. So these two are the only things that I have not mentioned here besides, let's say, this one here. However, I have mentioned the rest, and it's the most common. Greenhouse gas example, increase CO2, increase the house effect. Earth receives short wave from the sun emits the long wave. Greenhouse gas traps and absorbs long wave, right? And this causes the global warming the same time as the CO2 is rising, which means if CO2 is rising, that means the temperature will rise. And of course, it's all about CO2 rising. So I have mentioned most of the points, so I clearly got the points. But now that I know this mark scheme, you can say how greenhouse effect is a natural phenomenon, okay? It's not increased. That means it's naturally happening. And you can see that the most scientists accept, and there's yet not enough proof that says that man-made increases CO2 have closed the global warming. So that means we don't have enough evidence to prove the global warming is happening yet, according to most scientists as they believe. So this is mark scheme, but between these guys, the yellow ones, I have seen it so many times in the mark schemes when it comes to greenhouse effect. If you keep that, you will always get those points. So the next question, using a diagram, explain the interaction of short and long wave radiation in greenhouse gases in the atmosphere. So you have the sun and you have to put the earth right here for you, and they have shown you the greenhouse gases. So the first thing I would do is the sun, that I will put a line going like this, and I would label it as short wave. And then I will have some lines like this to say that heat is released. And then after this, I'll make a longer wave, and I will say this is a long wave. Oops, before I forget, this has to hit the sun, the earth. I did not do that. Just let me fix this. And then here, of course, it has to be here. So this heat is coming from here. Now, the long wave will come out like this if there was no greenhouse gases. But because there's greenhouse gases, I cannot do this whole drawing. What I have to do is I have to make the long wave coming here, hits, and then it comes back. And if I do this, it's showing what? It's showing that the long wave is trapped by who? By the greenhouse gases. And I can give examples such as CO2, water, methane. So I would put here examples. Always put the examples of green gases because you can get points for that. And I have mentioned here how the long wave is trapped by the greenhouse gases. And then eventually they can say this leads to higher temperature. I would put that just in case because you can get points. So let's look at the mark scheme. He says shortwave radiation, or UV, having its origin from the sun, gives off the light as short radiation, which we did was this direction here. Shortwave radiation passing through the greenhouse gases. So you see, I actually showed it passing through right here. The first time that I drew, I only did this, I would not get points. So you got to be very careful. I even almost missed it, but then I realized, oh, this whole thickness here is a greenhouse gas, it's not the earth. So you got to be very careful. Some radiation is absorbed by the earth and some is reflected. And that's what we put it here, and then it comes out. Reflect radiation is long wave radiation, and that's what I did. These guys that were like this, I said it was long. Long wave radiation being unable to pass through, being absorbed, reflected by the greenhouse gases. So you can see, let me make this more clear for now. You can see that the long waves, I showed that it was not passing the greenhouse gases, right? It was trapped in there. So award marks for the diagrammatic explanation of these marking points. So I did write here information, so I get points. Accept UV and RE as long as they are drawn in the correct wavelength. Diagram shows the greenhouse effect. So this is basically everything that I've written. This drawing that I just did here is the perfect drawing. Make sure you put all this information. Even the stuff that I wrote here, you can get points because it literally said here, award marks for explanation of these marking points. So me explaining the stuff, I also get the information. So here is another diagram that shows the greenhouse effect. And as you can see here, now they have drawn the sun, right? We have drawn the sun coming with the lines coming to hit the earth. And then you have some lines coming out like this. So now they're asking what is X and Y and what is Z. Okay, so state the type of wavelength of the radiation labeled X and Y. So the X here, we're talking, it's the short wave, and the Y, as you can see, is the long wave. Outline the reason for the change occurring at Z. Now Z, you can see that there is a greenhouse gases, and what are they doing? They're trapping the long wave. That's the reason why you can see that they're bouncing back into the earth, because the greenhouse gases are trapping it. So let's look at the mark scheme. So you can say short for the X, or ultraviolet, or UV as you wish. and the long is the infrared, which is the long. So it's gone down. So it doesn't have to be always infrared. You can say just long. Outline the reasons. Greenhouse gases present. Greenhouse gases such as methane, CO2, whatever the ones you want to put it here, absorb the long waves. On the lengths, infrared's blocked, leaving the atmosphere. Long waves, infrared absorbed, radiated, emitted by the earth. So here is just as I explained. This I talk about the greenhouse gases, trap the long waves. So I basically have mentioned here how they're blocked from leaving, how they're absorbed. I would mention also examples, always mention these examples here, okay? Because when you mention the greenhouse gases, or anytime you mention greenhouse effect, always put the examples of gases, CO2, methane, water vapor, because these guys are always in the mark schemes. They're always. And then this question says, outline how greenhouse gas interact with radiation and contribute to global warming. So in this case, we are basically talking about the whole process of greenhouse effect that we have been talking the whole time. So I'm not going to explain the greenhouse effect again. I'm just going to write the whole process, the sun, the earth, the short waves, the long waves. But in addition to that, we have to add about the greenhouse gases, right? Because they also have part of this. So the question is, how can I make the greenhouse gases increase? Like, how can I increase CO2 in the atmosphere? That's when I talk about deforestation. I can talk about combustion. I can talk about human activities, any kind of human activities we can think about besides deforestation, combustion. So we can all put in there, just say how CO2 is increasing, like cell respiration is increasing, and deforestation is cutting photosynthesis. So these are talking about what are the ways in which we can increase CO2, the burnings of fossil fuels. So let's look at the mark scheme. So first, look at that. Again, asking you to tell an example of a greenhouse gas, CO2. Methane, water vapor as another gases. Look, just mention examples of greenhouse gases. You get points. Sunlight radiation passes through the atmosphere. That's talking about the short wave. The CO2 atmosphere greenhouse gas absorbed and trapped to reflect some radiation heat. Again, talking about the long wave being absorbed by the greenhouse gases. Then CO2 atmosphere greenhouse allows short wave radiation to pass through, but the long absorbers of infrareds are not. So you see, this is just mentioned about the sun releasing the short wave into the earth. They go through. However, the long waves, they are trapped by the long waves are trapped by the greenhouse gases. So this is just explaining the greenhouse effect. Solar radiation, sunlight is short wave, and radiation heat emitted by the earth is long wave. So you can see that, again, allow answers presented clearly. They can see it's explaining the entire process all over again. You can see all of it. We're talking about short waves. We are talking about the long waves. We are talking about sunlight. We're talking about example. So it's always repetitive when it comes to greenhouse effect. Give the examples of the gases, talk about the short wave coming from the sun, talk about the long wave coming from the earth, talk about the greenhouse gases absorbing the long wave and that causing the temperature to rise. Now here, discuss the relationship between atmospheric carbon dioxide concentration and global temperature. It is exactly like the other question, right? It says greenhouse gases interact with radiation, contribute to global warming, but this one now says the atmospheric concentration and global temperature. It's again asking the same process. Everything is asking about the greenhouse effect. So that means you talk about the greenhouse's gases, you talk about the short wave, you talk about the long wave, you talk about the trap, and you talk about increasing the temperature. After this, you can also talk about how you can increase CO2 in the atmosphere. So this is again the deforestation, the combustions, all the other things that cause the CO2 to be rising in the temperature, any kind of other human activity that leads to having so much CO2 in the atmosphere. So the greenhouse effect keeps the earth warm. The earth temperature has fluctuated naturally. So this is basically the one part that we're talking about how the temperature has been fluctuating. Changing human activities led to increased CO2. CO2 absorb infrared, long-infrared radiation trapping heat. This is about the greenhouse effect. Increased CO2 correlates with increased lower temperature, which again, if you're saying that so much CO2 is rising, that traps a lot of long wave, which leads to increase in temperature. use of fossil fuels. That was when I told you about the combustion. When you're burning fossil fuels, you release CO2. Deforestation removes carbon sink, less CO2. Again, human activity. When you're cutting the trees are not absorbing CO2, so that means more CO2 in the atmosphere. Less of polar ice cause less reflection of surface light, more radiation of heat contributing to global warming. Of course, eventually the earth will become warmer, which will melt the ice. CO2 is not the only greenhouse gas. There are other greenhouse gases. Again, just mentioned water vapor, methane. And that's pretty much it. So here, just to make it clear, it doesn't have to be exact words, but if you mention the greenhouse effect, which again, the definition of greenhouse effect is just to make sure that the earth is warm, then you can talk about how the CO2 is actually trapping the long wave radiation, and how if you increase the CO2, that will increase the temperature. Talking about combustion, which you're burning the fossil fuels, cause more CO2 to be released, as well as if you're cutting the trees, there will be more CO2 in the atmosphere, and that leads to so much temperature rise that they're going to lose some polar ice in there. Give examples of other greenhouse gases besides CO2, like methane, water vapor, and you get the points. So you can see it's a very repetitive. When it comes to questions of 4.4, which is about global warming, greenhouse effect, there was a repetitive thing to do. First, define greenhouse effect. Second, give examples of greenhouse gases. Third, talk about the short and the long waves coming from the sun, emitted from the earth. Talk about the trapping of the long wave by the gases and how that lead to high temperature. And then if you want to say, how can you increase the CO2 in the atmosphere? We talk about combustion, we talk about deforestation, and you will always nail these questions. So here are other possible questions that come from this topic, such as the Industrial Revolution, which of course is increasing the CO2. We can also talk about the correlation between the CO2 concentration with the Industrial Revolution. Talk about 3 reasons why there's this huge debate that people are saying there is climate change and others say no. And talk about how the CO2 concentration affects the ocean pH, which I haven't seen much, but I think that's one of the questions that probably going to start coming, is a lot about how CO2 dissolves into water and then turns into this bicarbonate that eventually kills the coral reef. That question will start coming a lot more, so make sure you know that one. And that's pretty much it for questions of past papers when it comes to section 4.4. Thank you.